In machine learning, data comes in the form of the outcome we want to predict and the features that we will use to predict the outcome. We want to build an algorithm that feature value as input and returns a prediction for the outcome when we don't know the outcome. The machine learning approach is to train an algorithm using a data set for which we do know the outcome and then apply this algorithm in the future to make a prediction when we don't know the outcome. Here we'll use y to denote the outcomes and x's, x1 through xp, to denote the features. Note that the features are sometimes referred to as predictors or covariates. We consider all these to be synonyms. Prediction problems can be divided into categorical and continuous outcomes. For categorical outcomes, y can be any one of k classes. The number of classes can vary greatly across applications. For example, in the digit reader data, k is equal to 10, with the classes being the digits 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. In speech recognition, the outcome are all possible words we're trying to detect. Spam detection has two outcomes, spam or not spam. In this course, we denote the k categories with indexes k equals 1 through capital K. However, for binary data, we use 0 and 1. This is for mathematical convenience, something which we demonstrate later. Okay, the general setup is as follows. We have a series of features and an unknown outcome we want to predict. So it would look something like this, 5 features, unknown outcome. To build a model or an algorithm that provides a prediction for any set of values, x1 equals small x1 all the way up to x5, we collect data for which we do know the outcome, so we get a table like this. We use the notation y hat to denote the prediction. We use the term actual outcome to denote what we ended up observing. So we want the prediction y hat to match the actual outcome. The outcome y can be categorical, which digit, what word, spam or no spam, pedestrian or empty road ahead, or continuous, movie rating, house price, stock value, distance between driverless car and pedestrian. The concept and algorithms we learn here apply to both. However, there are some differences in how we approach each case, so it is important to distinguish between the two. When the outcome is categorical, we refer to the machine learning task as classification. Our predictions will be categorical just like our outcomes, and they will be either correct or incorrect. When the outcome is continuous, we will refer to the task as prediction. In this case, our prediction will not be either right or wrong. Instead, we will make an error, which is the difference between the prediction and the actual outcome. This terminology can become confusing since we use the term y hat to denote our predictions even when it is a categorical outcome. However, throughout the lecture, the context will make the meaning clear. But note that these terms vary among courses, textbooks, and other publications, so don't let that confuse you. For example, often prediction is used for both categorical and continuous, and the word regression is used for the continuous case. Here we avoid using regression to avoid confusion with our previous use of the term linear regression. Again, in most cases it will be clear if our outcomes are categorical or continuous, so we will avoid using these terms when possible.